Hi everyone, here we go. This is lesson 9. So let's take out your workbook and get ready. And lesson 9 is very short and it's about function notation part 2. So we're still on the topic of function notation. And function notation is just a way to write function. And then instead of y, instead of a second variable, you just write f of x. Basically, that represents y. Okay, so you can always write f of x equal to y. So x is x. Whenever you see x, it's just x. Whenever you see f of x, it means y. And this function notation allow you to write something like, for example, f of 2, which means what happened to y value when x is 2. So it's just a notation, just a way to write things in a very simple manner, and then everyone understand what the meaning of that. Okay, and now we can also graph a function. So when you have a function f of x, so given f of x is have to be a function equal to 3x plus 1. It means for every input x, the output will be 3x plus 1. You times x by 3 and add 1. That will be the output. X represent the input, and then the f of x represent the output, which is give you 3x plus 1 is the output. So therefore, f of x equal to 3x plus 1 is same as in the xy notation, y equal to 3x plus 1. Basically, it's the same. As I used an analogy last time, x and y emphasize two separate quantity, x and y. Okay, even though y is depending on x, but it's two separate quantity. You can see it, x and y, using two different letters. But then f of x equal x is still two quantity, y is f of x, but they emphasize they are related. So you write they are f of x, so it's y depend on x. So this is function notation, this is xy notation. So once again, you see this all the time. You just need to understand what it is. And then the input is the x, and then the output is the y. So in here, input is the x, the output is the y for the xy notation. It can also be the f of x, which represent the output as well. And x, you put it on the horizontal axis, you put it horizontally, left and right, y, you put it vertically. Okay, so use the graphic calculator to sketch the following. Well, what does it mean? On your graphic calculator, well, you can't type f of x, but you can just type y. So you just type 3x plus 1. This is same as having f of x because y is f of x. You just graph it. Here we go. Okay, so you will have a line that go like that. It will cross at 1. Okay. In each case, express the relation, example number 2, given in a function notation as an equation in two variables. So what are they asking? We just ask you to write them in xy notation. So instead of having y, f of x, you write y. And this is how you type that in the calculator as well. And then instead of g of t, well, you can just write y. So what's g of t? Well, it's just a function name. So whenever you see a letter with a bracket, this is a function notation. This represents a function, and that's just y. And then the function can have different name. It could be like f of x, g of, it could be f, g, or h, or anything. But usually they start with f, okay, and then g of x. And if you need another one, it's just t. And then it doesn't have to be g of x. If your variable is t, then you write g of t. So this variable and this variable in the equation should match. Express the relation of this in function notation. So you just write f of x, because your variable is x, so you write x. Just write something like this. The graph of the function defined by f y equal to f of x has equation of this. Write them in function notation. So they're using f of x, all right, and then it's equal to y, and y equal to that. So you just put them all together. Okay, so that's just the function notation, just showing you how to write things properly. And then example number 3, and then we are finished. See, it's almost done. Now, this one, you need to make the connection of the meaning of the function notation with the graph. Okay, so it's the same thing, but some of you may take some time to get it in to understand what's going on here. Now, it's asking you what is f of 5. So is it asking you x or y? Okay, it's asking you what f of 5 is. Well, f of x, f of a function is y. So asking you y. Given x is 5. Look here. So when you see this notation, it is asking when x is 5, what is y equal to? Does it make sense? All right. And then the function f is given on the diagram here. So what are you looking at? You're looking at when x is 5. What does it mean? So you look at this diagram. When x is 5, look at this graph. When x is 5, okay, my graph exists on all the x value, starting from -6, -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5. I'm looking at this point, right? What is the coordinate of this point? Is 5, -2. All right. Every point relate two quantities together, the input and output. This represent x, this represent y. Now with function notation, y is also f of x. All right. F of x. In this particular one, x is equal to 5. So you can also say f of 5 is this y value. F of 5 is -2. Okay, I hope you understand this one. Okay, some of you may have trouble seeing how does you connect the function notation with the graph. And with the function notation, what are they asking? Okay, let's check out the next one. F of -2. It is when x is -2, what y equal to. So this thing have two things. X is -2 on this graph is here, -2. And you look where is the graph, is this point. Okay, this point go -2, 3. So when x is -2, my function at -2 is 3. So this number is just your x, this number is just your y. All right? So what's f of 4? Which means you look at when x value is 4. All right? If you can read the coordinate 4, -1, then you know f of 4 is equal to -1. Okay, does it make sense? All right, next on. Next, write the order pair. Whenever you have a function notation written like this, you can always convert this into a point, which your input is 5, your output is -2, right? X and Y. Here, -2, 3. And here, 4, -1. Those are just the point I identify on my graphs there. Next one, state the value of x if. Now, what are they asking? You know what's the function equal to. The function equal to -1. It means y, right? Function equal to -1, y equal to -1. Now, what x is? What value of x will give you y equal to -1? So if you look here, y equal to -1 when x is 4. So the answer you write when f of 4 give you -1. Do you see this question is asking you for x, right? The example A asks you what's y. Example C asks you what's x. Okay, so let's check the other one. When y is 3, what x? Well, if you look at the graph, well, you see one answer here. But is it the only answer? Well, we find another answer right there. When x is 2, f of x is still 3. So you got two answers. They are f of -2 equal to 3. They are not necessarily one positive, one negative, but in this case, they are. Now, you may ask, does it make it a function? You say, wait a minute, does it make a function? It's still a function because we are saying for every input, there's only one output. For -2, there's only one output 3. For a 2, there's only one output 3. So every input, there's only one output, so it is a function. It doesn't say the function have to be unique. The output have to be unique. In this case, they are the same. But the input, for every input, there's only one output. Finally, at 4, well, there are 2 points. They're at 4, -1 and 1. Okay, well, once again, they happen to be one positive, one negative, but they doesn't have to be. Okay, so this is how you write the answer. You write them in function notation. D, use the notation in A to make a statement about point A and B on the graph. Okay, point A, I see the coordinate is 5, 1, right? Look at point A is -5, 1. So you want to write a statement similar to A using the notation there. So f of x equal to y. Look at the point. -5 is x, 1 is y. Okay, and then point B, so A is this, B is, look at the coordinate, is 6 negative 3. So you write f of 6 is negative 3. Okay? Write the x and y-intercept using function notation. Okay, x-intercept. Okay, remember x-intercept when y is equal to 0. So you look at this graph, where's your x-intercept? There are two x-intercepts, which is this point and this point. Okay, now they're not equal. I like it. Okay, one is negative 6, one is 3. So you write it this way. F of negative 6 equal to 0. F of 3 equal to 0. You have two x-intercept. You see it. There are two x-intercept, right? So a function can have many x-intercept, but a function can only have one y-intercept. Because for the input of 0, because remember what's y-intercept? It is when your x is 0. When the input is 0, there's only one output. Otherwise, it's not a function. So every function have only one y-intercept, but it could have many x-intercept, as many x-intercept they want. The answer is 5 here. Okay, so look at the graph. So complete the following statement. The domain of f means this function, which means this graph. All right, f of x is a function, is a y, it can be a graph. So if you look here, left and right, farthest left is negative 6, farthest right is go up to 5, 6, 7, go to 7. So x is between negative 6 and 7. And because it's continuous, it takes on all the values in between, you write x is in the set of all real numbers. And then the range of f, we'll look at the y. The lowest point is here, is negative 4. The highest point is 5. So you write negative 4 and 5. Oh, how come we don't write y? Well, y and f of x is the same. You can as well write like this, is the same. Okay, so that's the end of function notation. You once again see it in your future math courses. They always represent either using the XY notation or the function notation is the same thing. The benefit of using function notation is allow you to write things this way. Whenever you see an expression like that, you know it represents a point. Okay, so generally, whenever you see f of a equal to b, it it tells you a point. It's turned into a coordinate a and b. All right, because a is the x and b is the y. That's the end of this lesson. Goodbye.